help you with your problems for today. So it says, suppose you deposit $100 into a bank account where the interest is compounding continuously at a rate of 3.2%. How much would you have after 6 years? So first of all, guys, this is the key word. You're reading the problem and you see the word compounding continuously. If you see those words, you know you're going to be using the formula for exponential growth of curves, compounding continuously. So y equals p times e raised to the rt, where p is the put down amount, e is just a number. Remember, e is actually just a number. It's approximately 2.7, and we would not use 2.7. We'll use the e button on our calculator, but just keep in mind, that's just a number. And e is raised to the r times t. R is the interest rate, t is the time in. Now here's the catch. R is the rate. It has to be the decimal interest, not the percent. The decimal. So even though that's a decimal, that's the percent decimal. We want the number decimal for percent. So we've got to be careful. Okay, so let's plug in what we know. It says, suppose you deposit $100. So how much should we put in? $100. So we have y is equal to 100, and then e is just a number. So we have e, and then raised to the r. The r is the rate of interest, which is 3.2%. So we take our decimal, which is 3.2. We move it back 2 places. 0.032. So our rate in decimal as a number is 0.032. And then t is the time in the account. So how much time? 6 years. Okay, awesome. Let's see how much we made with this interest rate. Compounding continuously. Type it into your calculator. Everyone should be typing it in, so you know you can type it in. You'll do 100, and then do second ln. The ln key is on the left. Do second ln. That'll give you e. And then raise to the... Now this is both in parentheses in the exponent, right? So you have 0.032. Everyone should be practicing typing it in. Times 6, close your parentheses. Okay. So we have 121.17. Did everybody get that? So guys, we went from $100 to $121.17. So we made $21.17, right? In 6 years, which isn't that much, that's, to be honest, banks don't give very good interest nowadays. That would be lucky if you got $21 in 6 years, which is unfortunate. That's not that much. Banks' interests have gone down. Okay, any questions? Does everybody understand the problem? Okay, now this one you don't need to write down the whole problem, but you do need to pay attention because this one's different. It's the same in a way, but different. So let's read the problem. It says, suppose you have $300 in a bank account that you originally put 50 into. So I'm going to start again. Suppose you have $300 in a bank account you originally put in 50. So didn't we have 50 in the beginning and in the end 300? Okay, awesome. Then you were getting interest compounded continuously. Because we saw the words compound continuously, we know we're using PERT, so that's what I'm going to write down. Y is equal to P times E raised to the RT. So it says, getting interest compounded continuously at a rate of 2.7%. How long was it in the account? So won't this that we're looking for be T? Isn't T the time in the account? Yeah. Okay, so let's plug in what we know. The amount in the end was 300. So we have 300. That's the amount in the end is equal to P, which is the put down amount, which was 50, times E raised to the R. 2.7% as a number decimal is 0.027, and then T. T is the time in. So now it's just algebra, but it's actually a little bit trickier. This is on a secondary 3 level, kind of. It's actually on this level, but the way we solve it would be different in secondary 2 to 3. Okay, so first of all, we're trying to get T alone, right? So our first step is 50 is multiplied to this base E. So what does multiplication division? So we divide both sides by 50. So we get 6. 6 is equal to E raised to the 0.027 T. Now everybody listen up carefully. The only way to get T out of the exponent, which we need to, is to undo E using an inverse. The inverse of E is ln. That's how you learn it in secondary 3. However, there's the way you should do it in secondary too. Isn't this just an exponential function?
Yeah.
Isn't this just a straight line function? So isn't this saying when does this line equal this? Yeah, so let's use our calculators. Everybody should practice this. Go to y equals. In y1, type in 6. In y2, type in e, so second ln. And then 0.027 t, let's just use x, xt, variable doesn't matter. So x. Close your parentheses. Then hit graph. Now you might have to change your window if you can't see where they intersect. So let's look. Can you see where they intersect?
No.
No, so if not, then your window's probably not large enough. So I'm going to make, now if you look, it looks like it's starting to go up like this. So like this. So I need to see further on the x-axis. So go to window. For x max, that's how far up on the x-axis do you want to see. Let's change it to, I don't know, let's try 100. Hit graph. Now let's see if we can see where they intersect.
Yeah.
Yes. Okay. So now you'll use your calculator. Do second, trace, intersection. It says first curve. It's putting it on the line. There's only one intersection point, so we're good. Second curve. It's on the exponential. Hit enter, hit enter. X equals 66.36. So x is in years, and it does. Let's round to the nearest whole year. So wouldn't that be 66 years? Yeah? People? So it took 66 years for you to gain from $50 to get to $300. Questions on that? That's how you solve it in secondary 2. In secondary 3, you learn ln's, you undo e with the ln, then you divide by 0.027, but we won't go through that because that's secondary 3. Okay, questions? Okay, next one. You'll want to write down the problem, and you'll just do a rough sketch. That's good enough. So number 3 says, graph and state the domain and range of the function. So write down the function. F of x is equal to 2 times the square root of x plus 3 minus 4. Now, you should never miss a graphing problem because your calculator is going to do all the hard work, but I do expect you to be able to find at least the shifting and the starting point with your own mind. That makes it a lot easier too. So first of all, the shifting of function works the same for all functions. If it's grouped with x, it's a shift left and right, go opposite. If it's added on the outside of the function, in general, it's your shift up and down and your sign stays the same. So are we going to be going left 3? Grouped with x, we go opposite, left 3. We'll be going down 4. Right? Left 3, down 4. So let's start there. Start at the origin. If the function non-shifted, it starts at the origin. We go left 3, down 4. Put your starting point. Now from here, I'm okay with you graphing and using your table of values. So go y equals, type in 2 times the square root of x plus 3, close your parentheses, minus 4. Now you should know in general that a square root function looks something like this. So now do second table of values. Now I always go to my starting point, which is at negative 3. This is what you would need to do. Negative 3, negative 4. So find x equals negative 3. Does it say negative 4? Yes, right? So now if you go above that, below that, these x values, so I'm going to say error. Which makes sense because a square root function looks like this, so the function won't continue off this way for this problem. Okay, let's find the next whole number point. So, is it negative 2, the next one? So negative 2, negative 2. The next whole number point would be at over 1 of 0. The next whole number point is over 6 of 2. So now we can go ahead and draw this in. Questions? Okay, let's do domain and range. Okay, domain is x values, not x intercepts. Domain is not where does it cross the x-axis. Domain means what's your smallest x value to your largest x value in general for the whole function. Has nothing to do where it crosses the x-axis. So in general, what's the smallest x value that my function starts at?
Negative 3.
Negative 3. And it's growing this way on the x for x. To infinity, right? Good. Positive infinity. Infinity always gets a parenthesis because we cannot peg infinity as a number, but it does include the point negative 3. So bracket. Range is y values, not y-intercept. Y values, the smallest y value to the highest y value in this function in general. So the smallest y value was -4, and this function's growing upwards, right? Positive infinity on the y. Included -4. Questions on that? We should never get a domain and range wrong. Now I just want to point out, they might state it like this. Isn't domain x values?
Yeah.
Just so that you guys aren't like, what if it's written like this? They might say x values, so isn't it greater than? Aren't these starting at -3 to infinity? Wouldn't it be x values greater than or equal to -3? Aren't those a function? I mean, isn't that the domain for this?
Yes.
And then range is y values. So you might see it written like this. Our y values are greater than or equal to -4. Isn't that true? The y values are greater than or equal to -4. Okay, awesome. Okay, next one. Just write down this problem right here. What's the graph of y equals negative the square root of x minus 1 plus 2? So we're going to kind of start out the same way. Well, we are going to start out the same way. We're going to find our starting point. So it'll be right 1 up 2. So from the origin, write 1 up 2. Now we know it's a square root function. Square root functions generally look like this. Now I do want to point out something. We have a negative in front. That actually will take and reflect your function over the x-axis, which this is our x-axis, so it will reflect it, and it will look something like this. But your calculator will do it for you. So go y equals, now type in a negative, not a minus sign, negative square root of x minus 1 plus 2. So our starting point's at over 1 up 2, so start at 1 up 2. After that it will say error, because the square root function starts there for this shifted. The next whole number point is over 2 up 1. The next whole number point is over 5 up 0. The next whole number point is over 10 down 1. Do you see how it was reflected over the x-axis, everybody? Okay, let's do quickly domain and range. Domain, not x-intercept, the lowest x value in general. 1 to positive infinity. It is growing that way forever. Range is y values, lowest y value to highest y value. So let's go backwards on this one. What's my highest y value? 2. And isn't it growing down?
Yeah.
So negative infinity up to 2. You always put the smallest one first. That's why I wrote negative infinity first. Questions? So they would say, if we wrote it how I said you might see it, x value is greater than or equal to 1. That would be our domain. This one is y value is less than, because it's below or equal to 2. We're all good with seeing it both ways. Okay, awesome. Okay, last few. Write it down. Go, write it down. Okay, these are called function operations. It's been a little bit. So we have f of x is equal to x squared plus 2. We have g of x is equal to 2x. We're doing f times g of x. F times g of x. So isn't this notation the same thing as f of x multiplied by g of x? Yeah, right? That's what that means. So now with multiplication, you always use parentheses, guys. Multiplication, you always use parentheses. All of f of x, which is all of that, x squared plus 2, multiplied by all of g of x. G of x is 2x. So we have this 2x being multiplied to both terms. So we would distribute, that's 2x cubed, right? And then plus 4x. Can you combine those two things? No, that's an apple, that's an orange. You can't combine them. That's in standard form, so we're done. There's f times g of x. Okay, next one. G minus f of x. This is the huge red flag that most people mess up because they don't use parentheses. So g, this really means g of x minus f of x. So we have g of x, which is 2x, minus all of f of x. So minus x squared plus 2. So now mathematically, when we subtract, we know we're subtracting all of this. So we know what mathematically happens is we put a -1. distribute it in, that's negative x squared minus 2. Then we drop down the front term 2x. Now a lot of people then double, they say, so minus all that stuff, and they'll distribute the negative again. They'll get confused. So remember what you technically did. I mean, not technically, this is the technical math reason. But remember, isn't it cross line change the sign? So you see how this became positive, negative, negative. Everybody? Okay. Combine like terms, put it in standard form. We still have troubles with this for some reason. This is my highest degree, right? You always look from left to right, so wasn't it negative? So we have negative x squared, cross it out. Then isn't this positive 2x? People see the negative after and say minus 2x. No, you look from left to right. Plus 2x minus 2. Now it's in standard form. That's g minus f of x. Okay, this is our last one, then I'll let you work. And you need it, so write that down.
Is this the last one you said?
Yes. So we have f of x is equal to 2 raised to the x. G of x is equal to 3 times 2 raised to the x plus 1. We're asked to find f plus g of x. F plus g of x. So we know that really just means f of x plus g of x. So with addition, we don't have to be that careful. We can just put it in. So we have 2 raised to the x, that's f of x, plus g of x, which is all that stuff. 3 times 2 raised to the x plus 1. Now before we do this, which is kind of tricky, I'm going to ask you a simple question. A different, has nothing to do with this. Well, it does. X plus 3x. Can we combine them? You can't combine an x and a 3x.
4x.
Okay, that's, wait, how did you get 4? What's this?
1.
Oh, you're saying that's a 1x? 1x plus 3x is 4x's, right? And you could do that because wasn't the base the same? And we were adding. Okay, so let's think about this. 2 raised to the x plus 3 raised to the x's is how many 2 raised to the x's?
4x.
4, right? Aren't those the same base? 2 raised to the x, just like an x. So 2 raised to the x plus 3 times 2 raised to the x, isn't that 1? 2 to the x's. So 1 plus 3 is 4 2 to the x's.
What the heck?
Right? Now don't think about it that hard because people say, well, why is it multiplied? Well, why is 4 multiplied to x? Isn't 4 multiplied to x right here? Isn't 4x 4 times x? So isn't 1 plus 3, 4, 2 to the x's, 4 times 2 to the x, right? So we have 4 2 to the x's plus 1. So this would be our answer. Now we would not be able to combine them if they weren't both 2 to the x's. Are we all good with that?
How come you wouldn't just add the 2x and then the 2x?
Because does the base change? Did we double, that would be double dipping. Did we?
No, it wouldn't, because it'd be 4x.
No. 2 raised to the x plus 2 to the raised to the x is 2 of those 2 raised to the x. The base doesn't change. The base didn't change with x. You're multiplying.
No, I'm not.
You can't add a, okay, so, but do you get what I'm saying?
Yes.
I don't get
No.
what your question is.
So what did the 3 do?
1 plus 3 is 4. 2
Oh.
to the x's.
Okay.
1 apple plus 3 apples is 4 apples. The apple part doesn't change. Are they both apples? Yeah.
Wouldn't it be
No.
4 to the x?
No, it would not.
That's what I thought about too.
The apple part doesn't change.
That's your times.
That would be adding 1 plus 3 and then adding x plus x. That's what you're doing if you add the 2 and the 2. You're saying 1 plus 1 is 4 and then 2x.
So what are you doing with the 2x to make it?
Nothing. It's a 2 to the x, that's the apple part. So 1 to the x plus 3 to the x is 4 to the x's plus 1. Okay, so do pages 24 through 29. 24 through 29. Now here is the theme. 24, problem number 3, you're going to use this formula. Everybody listen or else you're not going to be able to do number 3 on page 24. Here is the formula. Now this is the technical formula. I'm going to tell you what each thing stands for real quick. A sub naught just means the initial value. The sub naught doesn't change anything. It's just like a P. So everybody understand that. So don't say, what do we do with the sub naught? So that's just your initial value. The 1/2 is 1/2, guys. T is the time in. H stands for half-life. It'll give you all those information. You just plug it into it'll give you all those things, plug it in. Number 4 is bonus. I've had a few students do it on their own without me helping them. And then number 26, everybody go to page 26 real quick. There's like a typo on page 26 because it says use the graph at the right, and there's not a graph. There is an XY chart, but there's no graph. So I'm literally having you cross out 2, 3, 4, and 5. So go to page 26, cross out 2, 3, 4, 5. So you're only doing problem number 1 on that. Is everybody comfortable with doing pages 20? Everyone understands that after tomorrow, we're moving on past 29. You need to be checking your answers and checking off your pages with me. Ready, set, go. Using LN, just so I can, those of you that are interested. So you two were the ones asking me, so you should be watching.
That was me. Oh, yeah. Higher.
So we have 6 is equal to e raised to the 0.027 times t. So to get t out of the exponent, you can't just drop it down. You can't divide a base. You guys don't understand this is a base e. So the only way to undo it is to undo the base. For e, it's ln. E is inverse is ln. So if you take the ln of this side, you got to take the ln of this side. So ln of 6 is equal to, then ln and e undo each other. So this drops down. You have 0.027t. To get t alone, our last step would be to divide by 0.027, right? Isn't that multiply the t? And then type it in to your calculator. ln of 6, close your parenthesis, divided by 0.027, and you get 66 years, just like we did by solving by method of grafting, which at our level, solving by grafting would be the more appropriate way of solving. Okay. I just thought some of you might be interested.
What is it?